Okay, so this title of this lesson is called Rational Expressions. What in the world does rational mean? What word do you see? What math word do you see in rational? Ratio. What's a ratio? Oops, didn't do my pen thing. Always forget that. What's a ratio?
Like two numbers and like a dot and other.
Okay, yeah. So if you say like 3 to 2 or something like that, okay, that's a ratio. But you could also write this like this. What is this thing? It's a what? In general, it's a fraction. Okay, so basically a ratio is a what? It's a fraction. It's a comparison. Okay, you compare one number to another number. That's what a fraction does. It compares this to this. Okay, that's what we're going to be doing. Now, an expression is just kind of an algebra thing. We're going to have x's and squareds and 3x's and 2x's and all that kind of stuff in there. Okay, so that's basically what an expression is. All right, so we're going to do algebra stuff with fractions. Well, today, the fraction part is going to be really easy. The next section that we do of this, you're going to have to add and subtract. But what's the easiest part of doing fractions? The easiest part of doing fractions is not addition and subtraction. That's probably the hardest part. What's the easiest part of doing fractions? It's not addition and subtraction. It's what? It's multiplying and dividing, okay? It really is. It's like the easiest part of doing fractions. So let's step back a step, okay? Let me show you some examples of rational expressions. This is in the book. Over x. I want to show you a couple things. Okay, this is a fraction. Would you agree? You got x's, you got cubes, you got an x, you got a number, you got pluses in there. That's an expression. It's a rational expression because you have a division right there. Okay, this is a fraction. That's called a rational expression. Now, you got to be careful with this stuff. When you have a variable on the bottom, can x be any number in the world? Could x be a negative number? Sure, you can have a negative denominator, can't you? Yeah. Can x be a fraction? Yes, you can have a fraction in the denominator. All right. Can x be a positive number? Yes. X can be any number in the world except for one number. Why 0? Because, anybody got a calculator out on them? Okay. Good. Punch in any number. I don't care. Put a number in and then divide it by 0. And we've talked about this earlier in the year, I think. Is it 0? What is it? What does it say on your calculator? Put any number divided by 0. Error. It says error. You are not allowed to divide by 0. Okay. I think I went through this, why it's true. I'm not going to go through that right now. You cannot have x equal to 0. Okay, why? Because it's in the what? It's in the denominator. That's correct. It's in the denominator. So 0 cannot be in the denominator. Everybody with me? All right. So what if, I'm just making this one up. This is, I don't know, x plus 2 over, I'll tell you what, let's go 3x plus 2 over x plus 1. Okay, this is a rational expression. It's a fraction. You got variables, you got numbers and all that kind of stuff. That's a rational expression. What can the denominator not be here? Can the denominator, or can x, I'm sorry, I didn't say that right. What can x not be? Any negative? Can x be a negative 2? Sure. Negative 2 plus 1 is what? Negative 1. Can the denominator be negative 1? Yeah, of course. The denominator can be any number except for what? 0. Can x be 0? Think. On the bottom, can x be 0? Exactly right. That's a perfect explanation. She said 0 plus 1 is 1, so yeah, it can, okay? That's what she said, and she's exactly right. So x can be a 0 here, right? Because 0 plus 1 is 1. Can 1 be a denominator? Absolutely. Again, what can x not be? Say it. Nope. What would make the denominator 0? A negative 1. Exactly right. Look at this. If x was negative 1, then negative 1 plus 1 is what? 0. then we'd have 0 on the denominator, wouldn't we? Okay, so what can x not equal in this problem? -1. X can be a 0. Watch, if x was a 0, 0 plus 1 is 1. And that's fine. X in this problem right here, it's perfectly fine for x to be a 0. Okay, because it's not the whole denominator, is it? There's more to it. It's 0 plus 1, which is 1. That's fine. But if x was equal to -1, -1 plus 1 is 0. -1 would make the denominator 0, and you cannot have the denominator being 0. All right, enough of that. I didn't really want to spend that much time on it, but there we go. All right, what if I had something like this? What if I had 3 times 4 over 5 times 3? All right, what would you do here? What if I asked you to simplify this? I think that's what they're probably going to say. Simplify. What if I asked you to simplify this? What would you do? You could. You could. I wouldn't, though. 3 times 4 is 12. 5 times 3 is 15. You get 12 over 15. Then what would you have to do to 12 over 15? You'd have to reduce it, wouldn't you? Okay? But it's already ready to be reduced right now. Do you see something?
Oh, the 3 and 3.
That's right. The 3 and the 3 will cancel each other out. Do you see that? I got a 3 on the top. I got a 3 on the bottom. They will divide each other out. So do I have to go 3 times 4 and 5 times 3? No, because it's already set up. I rigged this thing for you, okay, so that you could see the 3's there. They would cancel out. What's my answer? 4 over 5. Now, if you would have written 12 over 15, it would have reduced to 4 over 5. But you would have basically just done this. Does it make sense? What if I had this? Yeah, 4 over 5. That's the answer. So what if I had this? What if I had 3x over 2x? And I asked you to simplify that fraction. What would you do here? Oh, come on. You're just saying things. You just see 3 and 2 and you just said it. Think first. Think first. Okay? Why? Exactly right. You see, I'm following a train of thought here. Okay? See what I did here, and I'm probably going to do the same thing down here. Okay? Follow the train of thought. I canceled the same thing on top and bottom here. Do I have the same thing on the top and bottom here? I do. So that will cancel. That will cancel. What am I left with? 3 over 2. It is nice. Okay? So what we're doing. What if I had this? What if I had AC over BC? What's AC over BC? Yes, the C's cancel out. What are you left with? A over B. And that's your answer. Okay? What if I had this? This is example 1. You don't like where it's going? You should like it. Because that canceling stuff out, that's one of the easiest things of algebra, isn't it? Look at this. Now, does this look familiar? Why are we all packing up? Yeah, but I'm not finished, though. Look at this. What can I cancel out the x squareds? Nope. Because, watch this. What if I had 3 plus 2 over 2? Did the 2's cancel out? My answer is 3. No. You guys are just saying stuff. That's right. This is 5 over 2. The 2's don't cancel. You can't cancel when this thing is being added. The only time that you can cancel it is if it's being multiplied. Because multiplication and division are inverse operations of each other, so they cancel. Now, look at this. What do you think we're going to do with this? What did we just finish a quiz on?
No way.
Look, I told you earlier today, right, that we're not done with factoring. Let's do this real quick. I know the bell's rung. Sorry, Mr. Rao, but let's finish this up. Watch. Got an x here. What's going to be here? That's going to be a 2, and that's going to be a 2. What's this one? This is going to be what? A 2 and a 1. Now, let's simplify this. How can we simplify this? What happens? This x plus 2 and this x plus 2 cancel. My answer, oh, forgot the plus. And that is your answer. That's what we're going to be doing on this lesson. Okay? We're going to do more tomorrow. we're going to be a day behind because I expected to do more today, so don't worry about doing the homework tonight. We'll do that tomorrow, okay?